Hello, and welcome to another hands-on demo of the Attributor gem. This screencast will focus on the different advanced ways of defining requirements for attributes in both structs and hashes. In particular, we'll see how we can express direct and conditional dependency requirements on other attributes of the same hash or struct. So let's go to the editor and define a hash with some simple attributes. Let's just say that we have a class that we call a service. Let's define a service hash that it's an attributor hash, and we'll define a few keys. Okay, so let's define an ID key. That's a simple integer perhaps, and a key name key. That's a string. Let's get a couple more. One, let's call it a type for the service, and a category for the service. Okay. With this defined, I haven't defined any requirement yet, just the keys. I'm gonna load, say a service, load an empty hash, so no data because nothing is required, and I'm gonna simply print it. So if I run this, I should get no errors because I haven't defined any requirements. And that's what this screencast is about. So let's start seeing how we can define some requirements for these things. We've seen in the past that one can, go into any attribute or key and say required true. That will make that attribute to exist in order for the instance of the service to be valid. And while that's very nice sometimes when you have to scatter, a few direct requirements here and there, sometimes it's nice to group them all in one place, and that's what you can do with requires all DSL. So you can say, in this case, let's assume that when you create a service, you must provide a type and a category. So instead of going to both of the attributes and say required true, you can kind of group them in one shot. So if I do this and I run this validation, obviously it's going to say that I'm missing both the key and the category. Let me put in a nicer context. Let's call it service instead of the default $root of the object. So here we go. So now the type and the category are required. So let me fill them up. So let's just say type demo and category fun. Okay, run it again. That fulfills those requirements. All right, so those are basically the equivalent of the things that we've already seen in the structs and hashes. Now, sometimes what you want to say is that some pieces are required, but you need at least some of it to actually be valid. So let's assume that you use this class to say create a service, and when you create a service, I basically want to express that you have to either pass the ID or a name, but I do need one of them. So you would do that with at least one of, and in this case, ID and name. With this DSL, this is only going to be valid if either ID or name are set. So if I run that, I should see that I get this message that either one of the keys are required but found none in the definition. So if I can fix that, let's say passing the ID 1. Run it again, and we should be clean again. All right, so in the same way that you can say that you need at least one attribute, you can say that you need at most one attribute. And this is also pretty common too. So let me paste a few definitions here. Let's assume that this is a service, and when you define the service, you need to say if it's consistent, available, or partitioning. In the pure sense of the CAP theorem for the computer scientists, you can see that you can only say that it provides two of these three properties. So you do it in a very similar way. At most, say 2 of the consistency, availability, and partitioning. Okay, so that's the easy way to explain. You cannot really pass all three of them. You need at most two. You could pass only one. Maybe one service is only consistent and not available a partition. Okay, so that's the same thing. So if I run this actually, because I'm saying that at most two, this still matches what I'm saying. I haven't passed any. So there's another variation of the requirements that you can just say that you need exactly this many. Okay, so we'll take a look in a second. Another gist of expressing requirements is when you have several attributes that are really incompatible amongst themselves. So for example, let's assume that when you create a service, you can say you can create a price. So you can press the price in dollars or the price in euros, say. Okay? But you know that you cannot pass, if you pass one, you cannot pass the other. And this obviously works with not just two, but n. So to express that, you simply need to say requires exclusive of price in dollars and price in euros. Okay, so if I do that and I pass, let me pass it at the end here, price dollars 1, price euros 2. So I'm passing two things, and that should not be allowed. And in fact, I'm getting the problem, the error that says price dollars and price euros are mutually exclusive for the service. Okay. So that's another common way to say, hey, these two things don't go together. So if we pass one, don't pass the other. Great. So the other thing that I wanted to show is that there's another DSL that allows you to specify that instead of saying at most certain attributes or at least certain attributes, it allows you to say that you need exactly a certain amount of the attributes in the system in order to be valid. So that's done, requires exactly n of a list of attributes. Now obviously combining this with at most two in this case doesn't make any sense, but just for illustration purposes. So if I run this, what I'm gonna get is the fact that I didn't pass any, therefore I need to, the system says that exactly one of the following keys are required. So to fix that, I just can go in and add say availability true, one of the keys, and that should fix the system if I run it again. And here we go. We have no errors based on that. Now, this is when you have many requirements for a hash or a struct, this becomes a little bulky. So there's an easier way to express this from a cleaner way to express this, which is from a block. So you can put everything that has requires dot, you can put it in a block and then simply remove the requires prefix. So this is exactly equivalent. If you have one or two, this is, having a block is probably overkill, but if you have many, this may actually be much nicer from a reading perspective. The last thing I want to show is a pattern that is important to know because it's actually quite common in your applications, and that is the following. Imagine that you want to say, going with our price information, imagine you want to say, if you pass price information in, make sure you include dollars or euros. But it is okay if you don't pass or set any price information. That's the type of pattern. So this, to do that in this example, I would simply refactor these top level attributes into a substructure. Let me remove this and paste it down here. I would basically say, instead of having two top level attributes, I will have a key price, which has the dollars and euros sub attributes, and I will express the requirements inside that subhash, right? So if we have a price subhash, please pass exactly one of dollars or euros. Now if I do this, that means that if I don't pass any price, if I don't pass any price, this is equivalent of saying this, false. And this is exactly going to achieve what we want. If the whole price is not required, the system is not going to complain about anything inside. If you make it required, then all the requirements inside will actually be taken into account. And that's a common pattern of making a subhash optional when you don't always need it, but when you need it, you want a bunch of requirements inside to be applied. And that's the last thing I wanted to talk in this screencast. Thank you.